Hey everyone, and welcome to today's Explainer. We're diving into a design trend that's spreading like wildfire in new homes and major renovations, the in-wall aquarium. I mean, the allure of having a built-in focal point like this is totally undeniable, right? Instead of some bulky, freestanding tank eating up your living room floor, you get this incredibly sleek, flush window straight into an underwater world. But today, we're going to pull back the curtain and explore the reality of what it actually takes to pull this off safely, based on the source material we're breaking down.
Which brings us right to the absolute most important question you've got to ask yourself before swinging a hammer. Are you building a beautiful focal point or a totally costly maintenance headache? Because honestly, the stakes here are massive. If these projects are rushed or just kind of poorly planned, you aren't just risking a cloudy fish tank. You are literally risking massive structural damage to your house and the total loss of your aquatic life. It's basically a potential disaster hiding right in plain sight.
All right, Section 1, the visible dream, aesthetics and space.
Okay, let's dive into this. We've got two huge advantages when placing a tank directly into a wall. On one hand, you have that seamless aesthetic. The glass sits completely flush with the wall. It blends right into the architecture, giving you this absolute wow element for a living room, a hallway, or even a home office. And on the other hand, it's brilliant spatial planning. Since the tank is supported inside the wall structure, you actually gain back floor area for your furniture and foot traffic. Plus, with some thoughtful design, you can use integrated cabinetry to completely hide all that clunky clutter that usually comes with keeping an aquarium.
Moving on to Section 2, beneath the surface, the hidden challenges.
So, we really have to contrast those light, airy design concepts, the seamless aesthetics and save space, against the heavy, grounded realities of an indoor aquatic environment. I'm talking about massive structural weight and hidden leaks. These in-wall setups, they aren't just a quick cosmetic upgrade. They are major structural, mechanical, and electrical undertakings.
Listen closely to this next part, because it's the central constraint of this entire endeavor. A filled aquarium weighs far more than most walls were originally designed to carry. That water load is a fundamental threat to the structural integrity of your home if it isn't handled exactly right.
So the crucial point here is the actual math behind that weight. To put this into perspective, even relatively small tanks can add several hundred to, frankly, thousands of pounds of weight to a residential floor plan. It really depends on the dimensions and the glass thickness, but just let that number sink in for a second. Thousands of pounds, sitting exactly where a standard hollow wall used to be. Crazy, right?
And honestly, weight isn't the only hidden challenge here. Think about all the equipment you need behind the scenes. Heaters, filters, pumps, shutoff valves. All of that gear requires regular inspection, replacement, and cleaning. If your gorgeous design limits your access behind that finished drywall, or if everything is crammed into overly tight cabinetry, doing routine maintenance on this hidden clutter becomes incredibly difficult and way more expensive. Plus, if a leak does happen, it's a nightmare to contain if you haven't paired the build-out with proper drainage strategies.
All right, Section 3. The Blueprint 5-point renovation checklist. Let's get into the fix.
Let's move to the blueprint and see how this builds out. The source material gives us this exact non-negotiable 5-point checklist for any construction involving an in-wall tank: engineering, water containment, plumbing, electrical, and ventilation. Let's walk through them.
Step 1. Engineering and structure first. You absolutely must confirm that the wall can handle both the dead weight of the filled tank and any dynamic forces. So what does this mean for you? It means you need to work directly with a structural engineer. You cannot just wing this. You have to use a properly designed support frame based on the exact loading assumptions provided by your aquarium builder.
Step 2 is water containment and leak planning. You have got to plan for the absolute worst-case scenarios. Think about it. What happens if a seal fails? What if there's a crazy overflow event or a plumbing line just cracks? You need a design that includes waterproof barriers and drip management to stop water from ever spreading into your adjacent wall cavities or destroying your floors. If you can add a floor drain or some kind of active leak detection strategy early on, you absolutely should do it. Next up, Step 3, plumbing and overflow design. You have to map out exactly how water will be managed safely, especially when you're doing water changes or routing the filtration plumbing. The golden rule here is accessibility. Valves and fittings have to be completely accessible for service. Ensure your overflow systems are safely routed so you aren't tearing down beautiful, finished surfaces just to reach a simple shutoff valve. Step 4 is all about electrical safety. Aquariums demand incredibly reliable power for the heaters, lighting, and automation systems. This means you need to coordinate your outlets, check your circuit capacity, and install ground fault protection, or GFCI, with a licensed electrician. But it goes beyond just getting power to the wall. You have to plan service access. Cords, breakers, and components need to be reachable without you having to punch holes in your pristine drywall. And finally, step 5, ventilation, humidity, and materials. Look, aquariums evaporate a ton of water, and that spikes the humidity in the surrounding area. You have to select materials that can tolerate constant moisture exposure. And more importantly, you must build in appropriate ventilation pathways. If your design accidentally traps steam or humidity inside a closed wall cavity, you are basically inviting mold and wood rot to the party, and that threatens both the aquarium itself and the structural finishes of your entire home.
Bringing us to section 4, the final takeaway: systems over features.
And this brilliantly illustrates the core philosophy of a successful build, summed up perfectly by our source material. Treat it as a system, not a feature. An in-wall aquarium really only succeeds when the tank, the wall, the plumbing, and the electrical systems are engineered together from the very beginning. They aren't separate individual pieces, they're one living, interconnected system.
Now, if you're doing new construction, you've got a huge advantage because you can build this infrastructure right from scratch. But for renovations, the big trick is avoiding those finish-first decisions. If you prioritize how the drywall and trim look before sorting out the mechanicals, you are going to inevitably restrict access or conceal critical safety components. That's exactly why the source highly advises getting quotes from professionals who specialize in custom installations. You want to make sure your structural and waterproofing needs are absolutely locked in from day one.
So, we'll leave you with this final, provocative thought to ponder. A well-planned system is ultimately what keeps the centerpiece beautiful and your home safe. When you're planning out your dream in-wall aquarium, will your next renovation prioritize the beautiful centerpiece or the invisible system that keeps your home safe? Thanks for joining us on this explainer, and we will catch you next time.